Imagine a future where humanity no longer visits space, it lives there. A station unlike anything ever built, designed not for days, but for the future. A future that begins with a single module, then grows. One mission becomes two. Two become four. Four becomes something far greater. An entire generation of space stations, built one piece at a time. Laboratories floating above Earth. Astronauts pushing farther than ever before. A future where the next chapter of human exploration doesn't begin on Earth. It begins in orbit. It almost feels like science fiction. But every spacecraft, every module, every mission, every bold idea you're seeing is being built for a reason. Because something extraordinary is about to happen. For the first time in more than a quarter of a century, humanity is preparing to say goodbye to its only permanent home in space. That home is the International Space Station. Its story began in 1998 when the first module, Zarya, was launched into orbit. Built through a partnership of 15 nations led by NASA together with Roscosmos, ESA, JAXA, and the Canadian Space Agency, the station was assembled piece by piece over more than a decade, becoming the largest structure ever built in space. With 388 cubic meters of habitable living space, the International Space Station can accommodate up to 13 people, although its typical long-duration crew is smaller. Orbiting Earth every 90 minutes at nearly 28,000 kilometers per hour, it has been continuously occupied since November 2000, making it humanity's longest-running home beyond Earth. Costing an estimated $150 billion to build, and roughly $3 billion every year to operate and maintain, the station has hosted thousands of scientific investigations that have advanced medicine, technology, and our understanding of life in space. But after decades in the harsh environment of orbit, even this engineering masterpiece is reaching the end of its lifetime. NASA plans to retire the International Space Station around 2030. The question is no longer whether it will be replaced, it's who will build humanity's next home in space. That question has already sparked a new race. Around the world, several companies are working to build the next generation of commercial space stations, each with its own vision for humanity's future in low Earth orbit. Axiom Space plans to begin by attaching its first commercial modules to the International Space Station, allowing them to operate alongside the ISS before separating to form an independent orbital outpost. The company has already flown multiple private astronaut missions to the ISS, giving it valuable operational experience as it prepares to transition toward its own permanently crewed commercial station. Starlab is developing a next-generation free-flying space station through an international partnership that brings together expertise from across the aerospace industry. Designed to support scientific research, commercial manufacturing, and continuous human presence in orbit, Starlab aims to provide governments, researchers, and private customers with a successor to many of the capabilities offered by the International Space Station. Orbital Reef envisions a mixed-use destination designed to support research, industry, and future space commerce. Each project approaches the challenge differently. Each is racing against the same deadline. Because once the International Space Station is retired, the world will need a new home in orbit. But among all of these ambitious projects, one company chose a very different path. Instead of building everything at once, it decided to prove every step, one mission at a time. That company is VAST. VAST was founded in 2021 by entrepreneur Jed McCaleb with a single goal: to build the next generation of space stations. From the very beginning, the vision was ambitious. Not simply to place another laboratory in orbit, but to create a future where people could live and work in space for longer periods, opening the door to deeper exploration of the Moon, Mars, and beyond. But there was one problem. Building a replacement for the International Space Station isn't just difficult, it's one of the greatest engineering challenges of our time. Instead of attempting to build a massive station all at once, VAST chose a different path. Build something smaller, test it, learn from it, then build the next step. One spacecraft, one module, one mission at a time. That philosophy shaped everything the company would do next. From its headquarters in Long Beach, California, engineers began designing, manufacturing, and testing nearly every major system needed for a commercial space station. The goal wasn't simply to create impressive concepts, it was to build hardware that would fly. Before astronauts could ever call Haven 1 home, VAST first had to prove that its technology could survive the journey into space. Big ideas are easy to imagine. Proving them is something else entirely. Before building a space station capable of supporting human life, VAST needed to answer a simple question. Could it build a spacecraft that actually works? The answer came with Haven Demo. Unlike a crewed mission, Haven Demo wasn't designed to carry astronauts. Its purpose was to test the technologies that would eventually become the foundation of Haven 1. Computers, power, software, guidance, navigation and control, propulsion, radios, and ground operations. Every one of those systems had to perform exactly as expected. After launch, Haven Demo reached orbit and began transmitting data back to mission control. Engineers monitored every stage of the mission, validating critical hardware and software while gaining real-world experience operating their own spacecraft in space. But success wasn't measured only by reaching orbit. It also meant bringing the mission to a safe and controlled conclusion. After completing its objectives, Haven Demo successfully deorbited, demonstrating that VAST could manage an entire spacecraft mission from launch to re-entry. It was a milestone that transformed years of engineering into proven flight experience. The concept had been tested, the technology had been proven. Now, it was time to build humanity's next home in space. Haven 1 begins not in orbit, but on a factory floor in Long Beach, California. Sheets of aluminum are shaped into curved barrels, joined by precision welds, and slowly transformed into a pressure vessel strong enough to contain an atmosphere in the vacuum of space. VAST first built a Pathfinder to develop the tooling and manufacturing process. Then came two full-scale structures, one pushed through qualification testing, and one destined to fly. The flight article measures 10.1 meters long and 4.4 meters across, with a launch mass of approximately 14,600 kilograms. Its aluminum shell must withstand the violence of launch, maintain pressure in orbit, and protect its crew from micrometeoroids and fast-moving orbital debris. The qualification structure was deliberately tested beyond normal flight conditions. With its hatch and domed window installed, it underwent pressure and structural load testing in Mojave, California. Meanwhile, the systems that would turn the empty shell into a functioning station were being prepared. 12 solar array wings, batteries, propulsion, flight computers, life support, ventilation, thermal control, and 6 gyroscopes capable of controlling the station's orientation without constantly firing thrusters. Now, the flight structure has returned to Long Beach for final weld inspections and integration. The docking hardware has completed its fit check, and the station is beginning to come together as one complete spacecraft. Targeted for launch in 2027, Haven 1 will ride alone aboard a Falcon 9. Once deployed, it must power itself, establish communications through Starlink, stabilize its orbit, and begin operating autonomously. Only after the station is checked and ready will a second Falcon 9 rise from Earth, carrying 4 astronauts inside a Dragon spacecraft. And when Dragon closes the final distance and locks onto Haven 1, its crew will open the hatch into a completely new kind of home in orbit. As the hatch swings open, the first thing you notice isn't the technology, it's the space. Designed for a crew of 4, Haven 1 may be compact, but every centimeter has been carefully planned. Every surface has a purpose. Every corner has been designed to make life in orbit feel just a little more like home. Soft lighting replaces the harsh industrial look of earlier spacecraft. Warm interior finishes create an environment where astronauts can spend weeks living, working, and adapting to life in microgravity. Private crew quarters give each astronaut a place to sleep and enjoy a rare moment of privacy. A shared table becomes the center of daily life, where meals are eaten, plans are discussed, and experiences are shared while Earth passes silently below. Research is at the heart of Haven 1. Integrated payload facilities allow scientists to conduct experiments in the unique environment of microgravity, while flexible workspaces can support everything from technology demonstrations to biomedical research and future in-space manufacturing. Exercise equipment helps astronauts maintain muscle and bone strength during their mission, while environmental systems continuously recycle and monitor the station's atmosphere, keeping the crew safe and comfortable. But perhaps the most breathtaking feature is waiting overhead. A domed observation window, the largest single window ever planned for a commercial space station. From here, astronauts won't just look at Earth. They'll watch continents drift beneath them, thunderstorms flash across the oceans, city lights illuminate the darkness, and 16 sunrises and sunsets paint the horizon every single day. For a few unforgettable moments, the station disappears, and all that remains is the view. A space station is only as important as the people who choose to use it. Haven 1 is being built as more than a destination for astronauts. It is designed to become a laboratory where research in microgravity could lead to advances in medicine, new materials, biotechnology, and manufacturing that simply aren't possible on Earth. That vision is already attracting international support. France has signed an agreement with VAST for planned astronaut missions to both the International Space Station and Haven 1, creating a bridge between today's orbital laboratory and the next generation of commercial space stations. The Czech Republic has also partnered with VAST through the European Space Agency, expanding opportunities for scientific research and future commercial missions. These aren't just agreements, they are early signs that governments and researchers are preparing for the next era of human spaceflight. And as confidence in the mission continues to grow, so does the team building it. Building a space station is one challenge. Understanding what astronauts will need once they are inside it is another. That is why VAST has surrounded its engineers with people who have already lived the reality they are trying to create. Sunita Suni Williams brings decades of long-duration spaceflight and station command experience, helping shape crew operations, mission readiness, and life aboard Haven 1. Andrew Drew Feustel brings experience from Shuttle, Soyuz, the International Space Station, and Hubble repair missions, turning lessons from real missions into practical engineering decisions. Megan MacArthur contributes expertise in Dragon operations, robotics, and human-centered spacecraft design, helping VAST build stations around the people who will use them. Even the smaller details are being considered. VAST has designed a flight suit for launch, re-entry, and life aboard Haven 1, while an IWC mechanical watch has been qualified for spaceflight. Because building a station astronauts can trust requires more than advanced hardware. It requires the experience of those who already know what space demands. As space stations grow, so does one unexpected challenge: connecting them together. Today's docking systems were designed primarily for visiting spacecraft, allowing astronauts and supplies to move safely between vehicles. But building the next generation of large orbital stations demands something different. VAST has introduced a new concept called the Large Docking Adapter. Instead of connecting modules through relatively narrow passageways, the new design is intended to create a much wider connection between large station modules. That means easier movement for astronauts, more room for equipment, and the ability to transfer larger scientific payloads from one section of a station to another. But the real vision goes even further. The adapter is designed as a common standard that could allow future space stations and large spacecraft to connect using the same interface, making expansion simpler as orbital infrastructure continues to grow. It's one of those innovations most people will never notice, yet it could become one of the most important building blocks of the next generation of space stations. And VAST has already designed the station that will take advantage of it: Haven 2. The next step is far more ambitious. It's called Haven 2. Instead of a single station, Haven 2 is designed as a modular platform that can grow over time. Each new module expands its capabilities, creating more room for astronauts, larger laboratories, additional docking ports, and greater opportunities for scientific research and commercial manufacturing. Built around VAST's large docking adapter, the station is designed to connect its major modules through much wider passageways, creating an interior that feels more like one continuous station than a collection of separate spacecraft. The vision goes well beyond replacing the International Space Station. Haven 2 is designed to support government space agencies, international partners, private astronauts, researchers, and commercial customers, all aboard the same orbital destination. As new modules are added, the station can continue to evolve, expanding its capacity and adapting to future missions without starting over from scratch. It's a philosophy that echoes the International Space Station itself. Build one piece at a time, grow with every mission, keep improving. But this time, the foundation belongs to the commercial era, and for VAST, Haven 2 is only the next step in an even bigger vision. For VAST, Haven 2 is only the beginning. From the very start, the company's ultimate vision has been artificial gravity, one of the biggest challenges in human spaceflight. Instead of living in weightlessness for months at a time, future rotating space stations could create gravity-like conditions, helping protect astronauts during long-duration missions. That technology won't just change life in Earth orbit. It could become the foundation for future missions to the Moon, Mars, and eventually deeper into our solar system. Every station VAST builds is another step toward that future, a future where humanity doesn't just visit space, it lives there. But building humanity's future in space isn't only about stations. It's about the people who will live inside them. Every detail matters, from the largest structural components to the equipment astronauts rely on every single day. That's why VAST developed its own next-generation flight suit for launch, re-entry, and daily operations aboard Haven 1. Working closely with experienced astronauts, the suit was designed to improve mobility, comfort, and functionality in the confined environment of a spacecraft, while giving crews the flexibility they need during every phase of the mission. The same attention to detail extends to the wrist. In partnership with Swiss watchmaker IWC Schaffhausen, VAST qualified a mechanical pilot's watch for spaceflight. Built to withstand the demanding conditions of launch and life in orbit, it represents the same philosophy found throughout Haven 1, combining precision engineering, reliability, and practical design for the people who will depend on it. They're small details, but they represent something much bigger. Because creating humanity's next home in space isn't just about building the station, it's about building everything the people inside it will need. The International Space Station changed the way humanity sees space. Now, a new generation of stations is preparing to write the next chapter. Whether it's Haven 1, Haven 2, or the ambitious visions that may one day carry us to the Moon and Mars, one thing is certain: humanity's journey into space is far from over. Thank you for joining us on Wormhole to Cosmos. To our loyal community, thank you for your continued support. And to everyone discovering the channel for the very first time, welcome aboard. If you enjoyed exploring the future of space with us, consider subscribing and becoming part of our journey as we continue to uncover the science, technology, and discoveries shaping tomorrow. Until our next adventure, remember, the universe is vast, mysterious, and full of wonders waiting to be explored. Stay curious, keep looking up, and until next time, keep your eyes on the stars.